One of the most critical systems on a vehicle, a properly operating brake system, is essential for safe operation. This video covers the operational theory, system types, construction, operation, maintenance, troubleshooting, and A&P procedures for the braking systems found on Kawasaki vehicles. For detailed information on specific vehicles, consult the appropriate service manual. The brake system slows and stops a vehicle by using friction to convert energy into heat. Braking is accomplished by using either hydraulic or mechanical pressure to force brake linings or pads against a disc or drum. The friction created between the brake lining and the drum slows down the vehicle's motion, eventually bringing it to a stop. How efficiently a braking system accomplishes this task depends on several factors. The amount of pressure exerted on the brake linings. The more pressure exerted, the more friction created, which in turn slows the vehicle more quickly. The size of the contact area between the brake lining and the disc or drum. The larger the contact area, the more friction and more efficient operation of the system. The distance from the center of the vehicle's wheel to the center of the brake lining. The more distance between the two, the more leverage the brake linings have, which provides more braking power. Tire size, both circumference and width, along with the tire's composition. The larger the tire's circumference, the less braking power available. This is because there is reduced braking leverage. The brakes must overcome the reduced braking leverage in order to slow the vehicle down. A wider tire will provide better braking performance because of its increased contact area with the road. This wider contact area provides a better grip when stopping. The tire composition can also increase or decrease braking efficiency. Depending on the driving surface, a softer or harder tire compound will provide more grip to stop the vehicle. The condition of the brake system. A leaky, worn-out, or poorly maintained brake system can reduce braking efficiency to unsafe levels. Finally, the weight of the vehicle and its individual components. A heavier vehicle carries more momentum and thus is more difficult to stop. This requires the brake system to overcome the momentum in order to slow down and stop the vehicle. This also applies to individual components, such as larger wheels or tires. There are two main types of brake systems found on Kawasaki vehicles: disc and drum. Which system is used depends on the requirements of the vehicle, with some vehicles using both disc and drum brakes. A hydraulic disc brake system is made up of 8 basic components: a brake lever or pedal, master cylinder, hydraulic brake line, brake caliper, brake pads, and a brake disc. The system also uses brake fluid, which will be covered later in this video. The lever or pedal provides a means to operate the braking system. The lever or pedal pivots on a bolt or shaft and uses a return spring to return to the neutral position. Mounted on the handlebars or chassis, the master cylinder converts the movement of the lever or pedal into pressure. The cylinder is made up of an aluminum body, a piston, check valve, seals called cups, and a return spring. A brake fluid reservoir, either cast as a part of the master cylinder body or a separate reservoir connected with a hose, supplies brake fluid to the system through a feed port in the master cylinder. A hydraulic brake line provides a means of transferring the pressure created in the master cylinder to the caliper, connected to both the master cylinder and caliper with banjo bolts and washers. The hydraulic line is made of rubber covered by either a plastic or metal mesh covering. The brake caliper contains the brake pads and uses the pressure from the master cylinder to push the brake pads against the disc. The caliper body is usually made from aluminum and contains a piston, seals, and brake pad pins or bolts that hold the brake pads in place. A bleeder valve screwed into the body is used during servicing procedures. There are 2 types of calipers commonly used on Kawasaki vehicles: single and double action. A single-action caliper has 1 or more pistons on one side only. In a double-action caliper system, 2 or more pistons are used to push the brake pads against both sides of the disc. The advantage of the multi-piston system is that it provides more braking power. Mounted inside the brake caliper, the brake pads use the pressure from the caliper to create the friction used to slow down and stop the vehicle. Made from sintered metal and resin, they are a relatively soft but tough material that is heat resistant and has the ability to create a high amount of friction. Usually mounted on the wheel's hub, the brake disc provides a means to transfer the vehicle's motion energy into friction energy when contacted by the brake pads. Discs come in various configurations and sizes, but are almost always made from stainless steel for strength and rust protection. Brake system operation begins once the vehicle's operator engages the brake lever or pedal. As the lever begins moving, it presses against the piston inside the master cylinder, pushing brake fluid into the system. As the piston moves forward, the primary cup passes the small relief port inside the master cylinder, allowing pressure to build in the system. The more the primary cup moves forward, the more the pressure builds and the fluid travels through the brake line to the brake caliper. When the pressurized brake fluid reaches the caliper, it pushes outward on the piston, which in turn presses the brake pads against the disc. Because brake fluid, like water, does not compress, the brake pads are squeezed against the disc. The friction produced between the brake pads and disc causes the vehicle to slow down. When the lever or pedal is released, the master cylinder piston rapidly returns to its original position with help from the return spring. This causes pressure in the system to drop as the brake fluid flows through the check valve, relief port, and back into the reservoir. At the caliper, the piston retracts with the help of the seals. On a single-action caliper system, both pads press against the disc through the action of a sliding caliper. This system employs a caliper and caliper mount. The caliper slides on pins fixed to the mount. As pressure pushes the piston out, it also squeezes the caliper together, pinching the pads against the disc. Double-action calipers differ in that the caliper is rigidly mounted with pistons applying pressure to each side of the disc. This provides greater braking performance by allowing more uniform pressure to be applied to each brake pad. Another difference found on brake systems involves how the brake caliper is mounted. With a conventionally mounted caliper, the mounting bolts pass through the side of the caliper. When the brake is applied, the force is exerted against the caliper in a sideways twisting motion. With a radial-mounted caliper, the mounting bolts are in line with the vehicle's chassis. The force in this system is applied straight, in line with the chassis, increasing the brake system's performance. A hydraulic drum brake system is made up of 8 basic components: a brake lever or pedal, master cylinder, hydraulic brake line, backing plate, wheel cylinder, brake shoes, and a brake drum. The brake lever or pedal, master cylinder, and hydraulic brake line components found on drum brake systems are identical to those found on disc brake systems. The differences in the drum brake system start with the wheel cylinder. A backing plate provides a mounting surface for the wheel cylinder and brake shoes. It also protects the brake components from dirt and debris. Mounted on the backing plate, the wheel cylinder uses the hydraulic pressure created by the master cylinder to press the brake shoes against the brake drum. The body of the wheel cylinder is made from aluminum or steel. Inside the body are 2 pistons, cups, and a spring with cup expanders on the end. 2 rubber boots on the outside help keep dirt from entering the body. A bleeder valve screwed into the body is used during servicing procedures. Attached to the backing plate are the brake shoes. Using pressure supplied by the wheel cylinder, the brake shoes press against the brake drum to create the friction used to slow the motion of the vehicle. Made from sintered metal and resin, they are a relatively soft but tough material that is heat resistant and has the ability to create a high amount of friction. Return springs are used to keep the brake shoes away from the brake drum when the brakes are released. Mounted on the vehicle's axle, the brake drum provides the means to transfer the vehicle's motion energy into friction energy when contacted by the brake shoes. Like the disc brake system, drum brake operation begins when the vehicle's operator engages the brake lever or pedal. Brake fluid is pushed out of the master cylinder by the piston and pressure begins to build. The pressurized fluid then travels through the brake line, where the pressure pushes outward on the cups. In turn, the cups push against the pistons, engaging the brake shoes and press them against the drum. Friction created by the brake shoes and drum slows the vehicle down, finally bringing it to a stop. Similar to a hydraulic drum brake system, the mechanical system differs in that it uses a cable or rod along with an actuating arm and cam to engage the brake shoes against the drum. A brake cable or rod connects the brake lever to an actuating arm. Mounted on the outside of the backing plate, the actuating arm is connected to the actuating cam. The actuating cam goes in a hole in the backing plate with the actuating arm attached to one end. A flat surface on the other end is used to move the brake shoes toward the brake drum. When a mechanical drum brake system is activated, the lever or pedal pulls on a cable or rod. The cable or rod transfers the movement of the lever or pedal to the actuating arm, which turns the actuating cam, forcing the brake shoes into contact with the brake drum. The resulting friction between the brake shoes and the drum slow the vehicle down. A unique brake system called a wet brake is found on the rear brake of some ATV models. The wet brake system uses a series of friction and steel plates riding in an oil bath, much like a motorcycle wet clutch. When the brake is off, the plates are separated. When the brake is applied, a cable pulls on an arm, activating a cam system. The cam system rotates, squeezing the plates together, which creates friction. The oil used in the wet brake system is a special type and is the only type that should be used. Use of another type of oil could cause brake failure. For further information on the wet brake system, consult an appropriate service manual. Brake fluid is a specially formulated hydraulic liquid used in brake systems and is key to proper brake operation. Because liquid can't be compressed, brake fluid transfers the pressure created in a vehicle's master cylinder to its caliper or wheel cylinder. Moisture naturally surrounds brake systems. This is partially due to the fact that brake systems are vented to atmosphere, and in our atmosphere there is moisture. Normally, the moisture would accumulate and encourage corrosion at the brake system's metal parts. However, since standard brake fluid has a glycol or alcohol base, this moisture is instead evenly distributed throughout the fluid, preventing local accumulation and corrosion. This distribution of moisture continues with time until there is too much of it for safe brake system function, and the fluid must be eventually changed. This ability to retain moisture and still function normally is a major classifying category of brake fluid. Fluids with Department of Transportation ratings such as DOT3 and DOT4, the fluids used and recommended by Kawasaki, refer in part to the fluid's ability to accommodate this contamination. Incidentally, DOT5 brake fluid, though a higher classification, is a silicone-based fluid not recommended by Kawasaki. DOT5 brake fluid should never be used when servicing Kawasaki products. Use only the brake fluid recommended by Kawasaki in the vehicle's service and owner's manuals. Using other than the recommended brake fluid may cause poor brake performance or even brake system failure. Also, replace the brake and clutch fluids no less frequently than Kawasaki's recommended interval. You may find this interval in the appropriate service or owner's manual. Here's a few tips to follow when using brake fluid. Never mix fluids of different ratings. Always use a fresh bottle of the proper brake fluid when servicing a vehicle. Any bottle of brake fluid open for longer than 6 months should not be used. Use caution when adding fluid to a vehicle. Brake fluid can damage paint and plastic surfaces. If spilled, clean the area immediately with water. Before beginning any service procedure, consult the vehicle's service manual for recommended service intervals and proper service procedures. To ensure proper brake system performance, always use OEM parts and a new bottle of brake fluid. Pump up the brakes and test drive the vehicle before returning it to its owner. If replacing brakes that also operate as a parking brake, loosen the parking brake adjuster before making repairs. Then, once the repairs have been completed, readjust it. Always start with a visual inspection of the brake system. Make sure that the lever and pedal free play adjustments are within specification. Look for signs of leaking or physical damage, such as a leaking caliper or bent brake rod. Visually inspect brake pad wear or the brake shoe wear guide. Check the disc for grooves or signs of discoloration. Inspect fork and shock seals to make sure they aren't leaking onto brake components. The correct brake lever and pedal free play adjustment is essential to proper brake system operation. Too much free play may cause a delay in brake operation. Too little and the brake will drag, causing premature wear and possible brake failure. To adjust the free play, first consult the vehicle's service manual for the proper specification. On the front brake, pull back the dust boot covering the brake lever and locate the lever adjusting bolt. Loosen the lock nut and turn the adjusting bolt until the lever moves the specified amount. Now retighten the lock nut and install the dust boot. For the rear, the adjustment will depend on the vehicle. Not all models have free play adjustment for the rear brakes. Refer to the service manual for more details. The fluid in hydraulic brake systems should be flushed at regular service intervals as specified by the periodic maintenance chart. To change brake fluid on a hydraulic system, park the vehicle on a level surface and remove the master cylinder reservoir cap. Now remove the cap on the bleeder valve and attach a clear plastic hose to the valve. Run the other end of the hose to a suitable container. Open the bleeder valve and pump the lever or pedal. While pumping, be sure to keep the reservoir filled with brake fluid. Keep pumping until fresh fluid comes out of the hose. Once clean fluid comes out, pull the lever in or hold the pedal down and close the bleeder screw, then reinstall the bleeder cap. Top off the reservoir and reinstall the cap. Pump up the brakes and check for proper operation. The lever or pedal should be firm and there should be no leaks. If the lever or pedal feels soft, bleed the brake system and recheck it. Bleeding the air out of a hydraulic brake system is essential for proper operation. Air trapped in the system will cause the brake lever or pedal to feel soft and overall performance will suffer. With the vehicle on a level surface, remove the reservoir cap and top off the brake fluid. Now, slowly pump the lever or pedal until no bubbles can be seen rising from the reservoir. Remove the bleeder screw cap. If working on a vehicle where one or more brakes is activated by the same lever or pedal, start with the wheel furthest away from the master cylinder. Now, attach a clear plastic hose to the bleeder screw on the caliper or wheel cylinder. Place the other end of the hose in a suitable container.